Welcome student to PRAVIN PATIL College of Diploma Engineering and Technology, our department Humanity and Science. Our course Basic Mathematics, course code 22103. Again myself Mrs. Smita Shekhar Kamble. Our chapter is Coordinate Geometry, Unit 3, chapter number 6. Obviously, coordinate geometry in today's lecture we have to most focus about the lines and their slopes and their angles. Let us try. In this picture, what you see? It is railway track. It is the plug. This one pencil and this one is the snow riders. So, here we see these diagram what we have to observe. It is related to your coordinate geometry. We study about the straight line? Yes. We study about the parallel lines? No. So that's why I introduced this picture. This railway track, these are exact parallel lines. These nodes are exact parallel. These given lines are parallel and these also lines are parallel. So, we have to discuss parallel and perpendicular lines in today's lecture. Given diagram, perpendicular and parallel lines are given. Which are perpendicular and which are parallel? Yes, these are the parallel lines and these are the perpendicular lines. When parallel lines does not meet anywhere to each of them, but perpendicular lines make exactly 90-degree angles. That's why these are parallel lines and these are the perpendicular lines. Yes? Okay, we have to introduce. Parallel and perpendicular lines. Parallel lines, two lines never intersect. That is important. They have the same slope. M1 is equal to M2. Suppose M1 is the slope of first line. M2 is the slope of second line. They have different y-intercept. That means y1, y2, obviously two different points, and b1 not equal to b2, the coefficient of y-intercept. Perpendicular lines, obviously two lines intersect. They create four right angles. Oh yes, first 90 degree, this one second quadrant 90 degree, third quadrant 90 degree, and here fourth quadrant 90 degree. They have different slopes. M1 into M2 is equal to -1. But they can have same y-intercept. That is the coefficient of the y variables for the equation of lines. So it is introduction part about the which are parallel and which are perpendicular lines. The slope of parallel lines are equal and the slope product between the two lines are -1, then that are called perpendicular lines. That is the main topic behind these slides. Obviously, we have to check the slope of parallel lines. These parallel lines are given. They have the intersecting point. It is different way. So, we have to must target how to find now slope of the parallel lines. Yes, let us check. Two non-vertical lines are parallel if and only if they have the same slope. Vertical lines are parallel. Are these lines are parallel? Let us check. First line L in this diagram have the first point 6, 4. X1 is 6, Y1 is 4. It is obviously allotted in the first, it is 6 and it one is 4. Second point is given -4, 0. Obviously -4 is X2 and Y2 is 0. That is -4 and X2 is 0. Y2 is 0. That means it is allotted and in touching the x-axis. Same trick follow for the second line. Yes, P is the second line. Here 5 -1. It is the slope, that is the point is given x1 5 and y1 is -1. That's why it is lies in the fourth quadrant. And here -1 -3. X1 is -1 and x3 is, it is the y1, no, y2 is -3. So it is lying in a third quadrant. So in this diagram we have to allot it. So we have to find the M1. If the 2 points are given and their slope is found, we have to use the formula y2 minus y1 upon x2 minus x1. So that's why we have to take the 4 is the y2, 0 is the y1. So 4 minus 0. Next, which point we have to take? Yes, right. x2 minus x1. So x2 is we have to take the 6 minus x1 is minus 4. So 4 minus 0, 4. 6 minus of minus 4 plus 4. 6 plus 4 gives 10. 4 upon 10, obviously 2 upon 5 is the final answer. Now ML consider. Now MP we have to consider. MP because the line denoted by P alphabet. That's why we have to take MP. So what is x1? 5. y1 minus 1. Yes? No. We have to take x1 is here. Which variable? And x2 is minus 1 and y2 is minus 3. So we have to put the y2 minus y1 upon x2 minus x1. So here y2 is what? Minus 1. Minus 1. Minus 1. Obviously, yes, not? Yes, minus 3. So minus 1 minus 3. Then 5 minus of minus 1. So we have to take the minus 1 plus 3. Obviously 2. 5 plus minus of minus 1 is 6. 2 upon 6. 1 upon 3. M1 and MP. Slopes are 2 upon 5 and 1 upon 3. So ML and MP not equal to same. That's why these are not parallel lines. We have to check. If two lines are parallel, then their slopes are equal. That is M1 is equal to M2. 2x plus 3y plus 7 equal to 0 and 4x plus 6y plus 2 equal to 0 are two straight lines. Then are they parallel to each other? That is the question. We have to consider the first line L1 is equal to 2x plus 3y plus 7 equal to 0. We know that the straight line slope is given by M1 is equal to minus a upon b, the coefficient of x upon coefficient of y. So minus a is 2 upon 3 and minus symbol remaining. So M1 is equal to minus 2 upon 3. Now L2 line we have to consider 4x plus 6y plus 2 is equal to 0. So I take M2 is equal to the minus a upon b, coefficient of x is 4 and coefficient of y is 6. So final answer 4 and 6 divisible by 2. So 2 2s are 4 and 2 3s are 6. So final answer minus 2 upon 3. So now here M1 and M2 gives minus 2 upon 3. So given lines are parallel to each other. If two lines are parallel, their slopes are equal, and vice versa. If slopes are equal, then the two lines are parallel. So now we have to take the main thing here, and this slide we have to take. If two lines are perpendicular, then their slopes product equal to minus 1. That is M1 into M2 is equal to minus 1. If two lines are perpendicular, then their slopes products is equal to minus 1. That is M1 into M2 is equal to minus 1. Prove that the lines 3x minus 2y plus 6 equal to 0 and 2x plus 3y minus 1 equal to 0 are perpendicular to each other. So we have the L1 is equal to 3x minus 2y plus 6 equal to 0. The straight line slope is given by M is equal to minus a upon b. So M1 is equal to minus a upon b, coefficient of x upon coefficient of y. So coefficient of x is 3, coefficient of y is equal to 2, but minus 2 is there. So minus minus get cancelled. Final answer is 3 by 2. So we derive M1 is equal to 3 by 2. Next L2 is equal to 2x plus 3y minus 1 equal to 0. So that's why here M2 slope CV is given by, here I write mistakenly M1. You have to correct. M2 is equal to minus a upon b. So that's why what is the slope of a? Coefficient of x is 2. Coefficient of y is 3. So minus 2 upon 3. So we have know that M1 into M2. So we have to consider the left hand side. 3 upon 2 into minus 2 upon 3. 3 get cancelled, 2 get cancelled. What is remaining? Yes, minus 1 is remaining. So we prove that m1 into m2 is equal to minus 1. So given line equation, we have to prove that the line 3x minus 2y plus 6 equal to 0 and 2x plus 3y minus 1 equal to 0 are perpendicular to each other. Question is, are the lines 12x plus 3y minus 9 and minus 8x minus 2y is equal to 14 are parallel? Slope of 12x plus 3y minus 9 is what? Yes. What is that? A upon b. So 12 upon 3 is minus 4. So now we have the y is equal to, we have to convert y is equal to minus 4x minus 3. So let us check. Find the slope of now minus 8x minus 2y equal to 14. So minus a upon b is the slope. So minus a is what? Minus 8 minus bracket outside minus 2. But be clear that minus get cancelled, only minus 4 is remaining. So m is equal to minus 4. The slope of 12x plus 3y minus 9 equal to minus 9 have the slope m is equal to minus 4. And the slope of minus 8x minus 2y is equal to 14 have also m is equal to minus 4. So m1 and m2 are equal. That's why we prove that the slopes are equal, then the lines are parallel. If two lines are parallel, then their slopes are equal. 2x plus 7y plus 4x plus y are the straight line, then they we have to consider that is the minus 2 upon 3, minus 2 upon 3 are the slopes, they are parallel to each other. So exercise question is that 3x plus 2y plus 7 equal to 0 and 6x plus 4y plus 2 equal to 0 are two straight lines. Then are they parallel to each other? That is the homework question. So you have to must note down that thing. And we have to use which formula? M is equal to minus a upon b, coefficient of x upon coefficient of y. That is m1 first we have to solve and then m2 using this example. Okay. So let us take the next. Oh, slope of the perpendicular lines. These are the perpendicular lines shown in the figure. If two lines are perpendicular, then their products are equal to minus 1. m1 is equal to m2 is equal to minus 1. So I take the example just now. Prove that lines 3x minus 2y plus 6 equal to 0, 2x plus 3y minus 1 equal to 0 are perpendicular to each other. L1 is the given line, slope is 3 upon 2. M2 is the given line, slope is minus 2 upon 3, product is minus 1. That's we have to prove the perpendicular lines are there. Their slopes product is minus 1. Let us check what is the happen. Tell whether the lines are the given points are parallel, perpendicular or neither. Justify your answer. Line 1 is given coordinates are minus 9 minus 3, minus 6 minus 6 plus 7. Line 2 coordinates are minus 11 5 minus 7 2. In this example 2 points are given. We have the formula what? Yes, line 1 L1 have the slope formula m is equal to y2 minus y1 upon x2 minus x1. So y2 is what? 7 minus 3 upon minus 6 of minus 9. So 7 minus 3 is 4 and minus 6 plus 9 is 3. So 4 upon 3. Second line minus 11 5 minus 7 2. These are the points. Same trick apply. M is equal to y2 minus y1 upon x2 minus x1. So y1 is what? Yes, we have to check. Yes, y1 is obviously 5. y2 is 2. So 2 minus 5. Then x1 and x2. x1 is 5. x2 is 5. No. x1 is minus 11 and x2 is minus 7. So minus 7 minus of minus 11. So 2 minus 5 gives value minus 3 and minus 7 plus 11 gives 4. Look here, 4 upon 3 is m1. m2 is minus 3 upon 4. m1 into m2 we have to consider what? Yes, m1 or m2 not equal to 0. That means m1 not equal to m2. That means these are not parallel. Let us check it is perpendicular. Yes, For perpendicular, we have to take m1 into m2 is equal to minus 4. So we have to take 4 upon 3 into minus 3 upon 4. 4